In this video, we're going to talk about something called resonance. So the first thing is we need to define what resonance is. Resonance is a condition in which there are more than one valid Lewis structures for a molecule. So when there are more than one valid or correct Lewis structure for a molecule. So if you're looking at a molecule and you're drawing its Lewis bonding structure, and there are several different ways that you can put the electrons and arrange the bonds and they're all correct, that's when a molecule has what's called resonance. So an example here is SO2. So S has 6 valence electrons and each oxygen has 6 valence electrons. So in total, we have 18 valence electrons. So as it's drawn, I have 2, 4, 6, 8, 10, 12, 14, 16, 18. So I needed a double bond here between my sulfur and my left oxygen in order for sulfur to have an octet and each oxygen to have its octet. Well, another option is I could have put my double bond on the other side of the sulfur. So I could have had a double bond between the sulfur and the right oxygen. Since that double bond can go either spot and both of them are technically correct, we say that this molecule has resonance. So when a molecule has resonance, these both exist pretty much at the same time. So the electrons are constantly moving, and so it's kind of an average between the two. So instead of really having a double bond and a single bond, we really kind of have 1.5 bonds between each of these. So if you're going to be asked whether or not it has a resonance structure or whether or not a molecule has resonance, you're looking to see, does it have more than one Lewis structure? So let's look at an example. So the question is, does it have resonance? So we're going to look at two different molecules. We're going to look at CO2 and we're going to look at ozone, or O3, or trioxide. So we are going to draw the Lewis structures because that's the first thing we have to do to decide if it has resonance. So carbon has 4 valence electrons. Each oxygen has 6 valence electrons, and there are 2 of them. So that gets us a total of 12 plus 4, which is 16 valence electrons. So when I go to draw this Lewis structure, I'm going to put my carbon in the middle, oxygen's on the outside. I'm going to go ahead and put a single bond between each of them. So that gives 2, 4. So now I have 12 valence electrons left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since carbon doesn't have 8, I'm going to steal a pair from each oxygen to form a double bond with carbon. So now I have 2, 4, 6, 8, 10, 12, 14, 16 valence electrons used up. Everybody has an octet. So that's following still our just normal standard Lewis structure rules. So if I'm looking at this, there isn't a different way that those electrons can arrange themselves and the bonds can arrange themselves to give a correct Lewis structure. That's the only way to draw CO2 and it be correct and meet all of our requirements. So this does not have resonance. So we would say no, it doesn't have resonance. The next one we're going to look at is O3, or ozone. So each oxygen has 6 valence electrons. There are 3 of them, so I have a total of 18 to work with. And I'm going to just line up my O's, connect each of them with a single bond. So 2, 4. So I have 14 left. I'm going to start over here. 2, 4, 6. So I have 8 more. 2, 4, 6. I have 2 more electrons, so I'm going to put them on the middle. Okay, now I've used all of my electrons. This oxygen has 8, 2, 4, 6, 8. This oxygen has 8, 2, 4, 6, 8. This middle one does not, it only has 6, 2, 4, 6. So to fix this, we're going to take a pair of electrons from one of the oxygens and form a double bond. Now, you should be looking at this and thinking, which one am I going to take it from? That right there is a sign that there's probably resonance. Because since it doesn't matter which oxygen we take them from, we could take them from both. So I could take it from the left one and form a double bond, or I could take it from the right one and form a double bond. Either of those works. Okay, if we're looking at this and we're trying to figure out if there's anything else, let's just play around. Let's see, what if we make one of these maybe a triple bond? Does that work? 2, 4, 6, 8, 10, 12, 14, 16. Nope, that only got me 16 electrons, so that doesn't work either. That's not a valid structure. So these are our Lewis structures. So since there are 2 of them that are correct, does it have resonance? Yes, it does. So in order to determine if a molecule has resonance, you first have to draw the Lewis structure. Then you're going to examine it to see if there are different ways to arrange the electrons in the bonds. If there are, and those Lewis structures are correct, then yes, the molecule has resonance. If there isn't a way to arrange the electrons in the bonds and get correct Lewis structures, then no, it does not have resonance. And so that's how we apply the idea of resonance to our different Lewis bonding models.